Hello, welcome to the second video addressing database tools. I am Cosmin Man, and in this video I will show you how to address errors in geographical datasets. There are two types of errors that a typical GIS user will encounter: geometry errors generated by different processing algorithms or bugs or lack of knowledge, and topology errors. Typical topology errors include cluster tolerance, overlaps, and gaps. To find out more about the topology errors, search for ArcMap topology errors in your web browser and access the desktop help for fixing topology errors and the GeoBase topology rules and topology error fixes in ArcGIS. There are 7 steps in addressing geometry and topology errors. In step 1, I will show you how to repair geometry errors. Open Arc Catalog and browse to the dataset of interest. In this case, it is the lab example topology. In the search window, search for repair geometry. If you don't have the search window here, simply go to Windows and click on Search. Now, upon typing repair geometry, click on the search button and open the first option that you have. Simply drag in the input feature the feature data set that you want to fix the topology errors for and click OK. You see here the message the geometry is being repaired. If you want to see more about the geoprocessing, go to the geoprocessing menu and select results window. Go to the current session and click on repair geometry geoprocessing tool is running, and further click on the messages to see if any topology errors are being repaired. As you can see, there are some topology errors that have been repaired. You can expand the window here to see what it says in each of these messages. So for example, in the first message it's being said that the full report is being stored in a text file which is located on a temporary folder on a C drive, and then in the next 3 messages it tells me what kind of geometry error has been repaired. Once you finish the repair process, you can safely close the Arc catalog. In step 2, I will show you how to eliminate sliver polygons. To do this, you will need to open ArcMap, so navigate to your Start menu and go to All Programs, ArcGIS, and ArcMap. Upon opening, just click Cancel on the first Getting Started window. To add the data you're interested in, you can do it in 2 ways. You can simply go to this Add Data button here on the menu, or you can navigate to your catalog on the right hand side and browse to the location of where your data is. If you don't have these windows here, simply go to the menu here on the top and click on the button of which window you want it to be added on the sidebar. I have navigated to the location of my data that I fixed the geometry errors for and simply drag it into the layers. Next is to eliminate sliver polygons. However, to do this, we need to ensure that the dataset is single part, not multi-part. The difference between multi-part and single-part polygons are explained in this picture. A multi-part polygon has one record in the attribute table and is being formed of 4 individual polygons. When this multi-part feature is being split into single parts, it will result into 4 single part features which will occupy 4 records in the attribute table. To convert a multi-part feature to a single part feature, in ArcMap go to the search window, type in multi-part to single part, and select multi-part to single part data management processing tool. Simply drag into the input feature the data set that you want to process, and in the output feature class, press the browse button and browse to the location of your geodatabase and give it a name, for example _single. Save and OK. Again, you have the single part to multi-part confirmation here, confirmation that it was successful. Similar to the Arc catalog, if you want to see the geoprocessing results, go into the geoprocessing menu and click on the results window, current session, and see all the messages. So here it tells me that it took 2.75 seconds to run, Now you can remove the first feature dataset that we added to this ArcMap session. Right click on it and click remove. Next step is to eliminate any sliver polygons. Sliver polygons are very tiny polygons, as shown in this image in the yellow, which occur between larger polygons. For example, if this is an input dataset, the geoprocessing tool will eliminate these yellow polygons and the result will be in the output here. To eliminate sliver polygons, simply go to the ArcMap, select the database for which you want to eliminate sliver polygons for, go into the selection menu, select by attributes, scroll all the way down to shape area, double click on it, and in the window down here, type in less than and the area of the sliver polygons that you want to be eliminated, and type in 1000. So we want to eliminate all the polygons which have a shape area less than 1000 square meters. Remember, in a file geodatabase, any feature class or feature dataset, which is a polygon type, has the area in square meters by default. And click OK. Now all the polygons that have an area less than 1000 square meters are being selected. So typically these polygons occur on the side of the land base. So very, very insignificant results on the entire geoprocessing. Once you selected the features you want to be eliminated, go into the search window again and type in eliminate, hit enter, and select eliminate data management tool. Click on it. In the input layer, drag in the dataset with the selected features that you want to be eliminated. In the output feature you have to rename again here single underscore E1. I type in 1, 2 or 3 depending on how many elimination tools I'm running. For example, there are large datasets where more than one instance of the eliminate tool needs to be run in order to get rid of all the sliver polygons. Click save. And then OK. Again, to see the results of the geoprocessing, go into the geoprocessing menu, go to the results window, click on eliminate geoprocessing tool, look at the messages, and see how many of the features have been eliminated. So it has been eliminated 933 features. So if we look again to the attribute table here of the data set that we wanted to eliminate sliver polygons for, 1059 polygons have been selected for the elimination purposes. However, only 933 of those polygons have been eliminated. Therefore, we need to run the eliminate geoprocessing tool again. To do this, simply remove the initial database, and on the one with E1 at the end, go to selection menu, select by attribute, scroll down to the shape area, double click on it, less than 1000. Click OK. In the search menu, you already searched for eliminate, so you don't need to type in again. Open the eliminate tool again, drag in the feature, browse, rename it E2, click save, and OK. In the results window, I can look at the second eliminate instance and look at the messages. So it only eliminated one more feature. Therefore, I need to manually remove the others. To do this, you can close the results window so you can have more access to the database, and remove the initial database E1. And now we're going to edit E2 until we get rid of all the sliver polygons. To edit, right click on it and go to the edit features and click on start editing. If you don't have this edit toolbar in here, simply right click on the area here and go to the editor toolbar and select it. It will automatically be added to your toolbars. To start the editing process, right click on the database you want to edit and open the attribute table. Go into the table options, select by attributes, scroll down to the shape area, type in less than 1000 square meters, Click Apply. You can close this window, and in the attribute table, click on Show Selected Records All. So we have 125 records that have not been eliminated. So we need to figure out why these were not being eliminated. So let's zoom into the first record. So as you can see here, it's just a simple line, so we can simply delete this record. We can go to the next one. Same thing, delete. Next one, delete. Next one, delete. You can individually check for all these records, but let's look at the shape area of these records. So it's very, very small. Remember, this is in square meters. Very, very small. So it's safe in this particular database to delete all the selected features. So simply click on Delete Selected Features, and all the 121 features that were left are being deleted. You can close the attribute table, go to the editor menu, click Save Edits, and click Stop Editing. You can zoom out to see the full database again. Click on this Full Extent button here, and this is the database that has all the slivers polygon eliminated. If I want to double check on that, I just right click on it, open the attribute table, select everything, go to the shape area, and sort ascending. So the smallest size polygon is 1003 square meters, which is above 1000 square meters, the threshold that I use to eliminate slivers polygon. The next two steps involve creating a topology and validate it. It can be done in two ways. It can be done in ArcCatalog or in ArcMap. In ArcMap, you can simply go to your catalog window, browse to the location of your database. Once you browse to the location of your database in ArcMap, create a feature dataset inside the FileGeo database. Right click on the FileGeo database, go to menu New, and Feature Dataset. New Feature Dataset, and give it a name. I typically type in FD from Feature Dataset. Click Next. In the coordinate system section, you want to match the coordinate system with the database you're creating the feature dataset for. So go here in the coordinate system menu, go to Import, and browse to the location of your dataset. And we're looking at lab example topology single E2. Click Add, click Next, Next. Don't change any of these values, and click Finish. Now a feature dataset is being created inside the FileGeo database. The next step is to remove the dataset from the ArcMap. So right click, remove, go back to your catalog window, and simply select the lab example topology single E2 and drag it into the feature dataset. Now you can expand the feature dataset and you'll have the lab example topology single E2. Inside the feature dataset, right click on it and click New to create a topology, and select topology from this menu. Click Next. You can rename the topology if you want. On the cluster tolerance, insert 0.1 meters. Click Next. Select the dataset. Click Next. Next. And in this window we need to add the rules. So the first rule we need to add, we don't want these polygons to overlap. Click OK. Add another rule, we don't want to have any gaps. Click OK. Next. Finish. And yes, I want this topology to be validated. Now the topology has been validated, go back to your ArcCatalog window and look at the topology under the feature dataset you just created. Select it, right click on it, and click on Properties. You have several tabs here. Go to the Errors tab and click on Generate Summary. So you see I have 54 errors for must not have gaps, 6 overlaps, and no errors for cluster tolerance. Usually the cluster tolerance errors come from not eliminating all the sliver polygons. You can click OK at this stage. In the next step, I will show you how to fix topology errors in ArcMap. To do this, in the ArcMap, go to your ArcCatalog window and drag in the topology file into the layers window. It will ask you if you want to add all the feature classes that participate in this topology, and you click yes. To fix errors again, we'll need to go into the editor mode. So you can either go to the editor menu and click start editing, or you can go to the database you want to edit, select it, right click, and go to the edit features and click start editing. To fix topology errors, you will need this topology toolbar. If you don't have it, again, right click on anywhere in here and go to the topology toolbar and select it if you don't have it, add it already. The next step is to open the error inspector window. So click on the topology toolbar while you're in the editing mode, and this window will open down here. In order to see the full database, go to the full extent button again. In the error inspector window, you can select to see the topology errors from must not overlap, and click search all the errors in the visible extent. So I have 6 errors. Let's zoom at each individual one and fix them. So if I select one, right click and zoom to, I can see it here that it overlaps perfectly on another polygon. The simplest fix is to right click on the selected error and click merge. This will merge the two polygons. To see which polygons, simply click here and here. So they're both the same. Click OK. Next error, zoom to, same thing, right click, merge. Next error, zoom to, right click, merge. Next error, zoom to, right click, merge. So I do this with all the errors without zooming. Once I'm done, I go again to the full extent, and in the topology toolbar, I select validate topology in current extent. Once the topology is being revalidated, go to the search now again for the must not overlap errors and see if you have any other errors left. None are being left. Then I can move on to the next error type, which is must not have gaps. While in full extent and editing mode, click on search now. So it found 54 errors. Let's see how these errors stack up. Select the first one. The first error refers to the entire land base. So in this case, I can add an exception because this is not an error. Mark as an exception. Let's go to the next one. Select it. See with the black lines what is located. No. Right click, zoom to. So this is a gap right here. So the easiest fix is to right click on it and say create feature. Note that this newly created feature will have null values in the attribute table. Zoom to the next one, same thing, create feature. Zoom to the next one, create feature. Now if you want to fix all these errors in one go, select them all. You can select them all by selecting the first one, scroll down to the last one, while pressing shift key, click on the last error and they're all selected, right click and create feature. Go again to the full extent, validate topology in the current extent, and search for any other errors must not have gaps. None is being returned. From this pull down menu, go to the errors from all rules, select that and click search now to see if there are any other errors from all the rules in the topology. None is being returned. At this stage, I can go to the editor menu and click save edits, editor menu again and click stop editing. I can close the error inspector window and again zoom to the full extent. Now the resulting dataset, it is already fixed for topology errors and geometry errors. The next step is to move the dataset back into the geodatabase and delete the empty feature dataset. You can do this in ArcMap or ArcCatalog. I'll show you how to do it in ArcMap. Once you're done editing, you can simply remove the topology and the database from the layers window. Go to the ArcCatalog. delete the topology selected, right click on it and say delete, and click yes. Now you can drag back the lab example topology single E2 into the topology geodatabase, and you can rename it, for example, lab example final. Because all the others are intermediate, you can either delete them or you can move them into a temporary file geodatabase. In this case, I prefer to delete them from here. So select each single one of them and click delete. I can also delete the feature dataset because it's now empty. So the end result is a file geodatabase that only has one feature dataset, lab example final, which is a dataset that has been fixed for geometry errors and topology errors. In the last step, I will show you how to zip the geodatabase folder and create a file ready to be shared with other people. At this stage, you can safely close the ArcMap, no changes, and open Windows Explorer. In Windows Explorer, you browse to the location of your database, and in this case, it is lab example topology geodatabase. You right click on it and click send to compressed zip folder. And you rename it or not, it depends, it's up to you. I typically leave it as it is and just click enter. This brings me to the conclusion of this video. If you have any questions, feel free to contact me via my email address.